Good afternoon and welcome to the Preservation Association of Lincoln Brown Bag Lecture Series. My name is Eileen Burke and I'm the coordinator of these brown bags. Our lecture today is sponsored by the Preservation Association of Lincoln. If you're interested in these programs, please join our membership. You can go to preservelincoln.org to join. Our speaker today is Robert C. Ripley. Bob is the Capitol Administrator in the Office of the Capitol Commission at the Nebraska State Capitol Building, a position that he's held since 1983. Bob is a native of Lincoln, Nebraska. He has a Bachelor's of Architecture degree from the University of Nebraska-Lincoln and is a registered professional architect and a recent fellow to the American Institute of Architects. Bob's talk today is titled, The Nebraska Capitol Tower Elevator Upgrade. Please join me in welcoming Bob Ripley.
Thank you, Eileen, for your very kind introduction. It's a pleasure to be here and to talk to you and give you another update on what's going on the Capitol. We call it elevator upgrade because it isn't. This is the fourth generation of renovation to elevators in the Capitol. There are a total, and I'll catch my first slide here. I thought I would anyway. Yep, that worked. Thank you. It's always good to have tech in the audience, especially for a fellow like me. The photo you see, of course, is a familiar shot taken from the downtown Lincoln area. And to remind you a little bit of our fourth grade Nebraska history course, the building is a product of construction from 1922 to 32, with landscaping done in 1934. And it was during that original construction, of course, this was one of only two designs in the competition to design a state capitol, one of only two that had a significant tower. There surely would have been elevators in any of the 10 designs that were submitted for the competition, but clearly when you get a tower structure, there's no alternative. You simply can't rely exclusively on stairs. The original tower construction for the elevator was done at a time when stairs were still very much in active use. And what you see here is the starting phase, actually more the mid-phase of second construction. You'll notice it looks at the base of the tower. You can see the structural steel in place, and they're just about to top out second construction. There's a big chunk of the tower still in steel, but they didn't really finish it all completely until about 1930 when they started building third construction. Now this picks up where the last photo left off. You'll notice in the foreground there is some blank brick that you see, which is essentially the legislative chamber, which was the last piece of the building to be built. And what you're seeing here is structural steel, the piece that's in the air, being lifted and is being placed to start the 14th floor memorial chamber. Notice, if you will, up the corner on the left-hand side of the tower, the corner is very defined by a vertical steel column. When you get to the very top level, you can see that corner turns into a 45-degree faceted piece of steel. That indicates we're at 14th floor and we're starting to put stone around that, and that is the location where the tower ceases to be square in floor plan and starts to become an octagon. And that means we're in great shape to put the elevators in, because elevators only rise from essentially basement, some 300 feet up, to the 14th floor, which is about 2/3 the height of the tower, and from that point on, where the octagon and the drum and dome are, has no elevator access. Now what you're seeing in third construction, the tower elevators are in the four corners of the tower, as most of you know. The original Capitol had 8 elevators in it. Take that back. Let me step back once. There are a total of 8 elevators in the building now, 6 of which were built when the building was initially constructed. 4, the ones that the public knows about, are the 4 public elevators that provide access to the tower, only 2 of which, the 2 north towers, go to 14th floor. The 2 south towers, southeast and southwest corners, rise to the 12th floor, and those lower level elevators are used predominantly by staff of the state who work in the tower, because the 14th floor elevators, of course, must be used for public access to the 14th floor and the outdoor viewing galleries. The original elevators were installed at roughly this time. 1930 would have seen the original 4 tower elevators put in place. In 1953, the tower elevators were renovated for the first time, and it involved only 3 of those 4 elevators. The southeast was left as a manually operated elevator with a dial, which some of us, as old as I am, can remember going into a store, perhaps Miller and Payne downtown, where they had a standing operator in there, and they had a manual control because there were no buttons for automatic lift to and from floors in the tower. The first renovation in 1953, along comes 1975, roughly 20 to 25 years later, and 1979 we renovated all 4 of the tower elevators, which allowed us to also reproduce them. The 1950s construction had Formica-clad elevators in the 3 that were renovated, and in 1979 we were picking up interest in restoring the building, and that's when we replicated the original tower cabs, which were inlaid walnut with holly and ebony set into them, and it had a coffered ceiling. Essentially the cabs you see today, which are reproductions of those that were constructed in 1930. Those cabs were put in place. I was involved in that work as a very young architect, and they lasted again about another 20, 25 years, and renovation of those were necessary, and that's what we'll talk about today. We restored, if you will, the cabs, which were reproductions, and we added an element that was original to the building but had not been realized or replaced until we started our project in 2000, from 2011 to 2013. Our most recent renovation was a $2 million project, and our office, our staff did a great deal of the work, and I'll show you that in succeeding slides. Our general contractor was Kingery Construction, and their elevator subcontractor was O'Keefe, and both did a superb job for us, putting all the elements back into the building that had been missing or that we restored as part of this work. This shows, as you can see on the left-hand side of the screen, the old manual control panel. Every elevator had those probably prior to about perhaps prior to World War II. And after that point, automatic controls became the norm. And here you see on the right-hand side a call station that occurred on every floor in the tower to call an elevator from the position you were standing to either rise up or down within the tower. These are elements that we used. Picture, if you will, keep a picture of the elevator panel on the left, the ornamental border, and 2 rectangular boxes above and below the control. That same composition was rearranged to create the new control panels that we have in place today. The call station box that you see on the right-hand side was in most cases reused, and in one instance we had to reproduce them for elevator code purposes. The elevators that you walk into today look much like they did when they were first built. Oh, thank you. Much like they did when they were first built. However, the controls and all of the code material that you would expect in a modern elevator today is in fact new. The machine rooms, elevator projects, a bit like an iceberg. What you physically see is about 15% of the total cost of the project, because the real heart of the cost of the project is in the elevator shaft or hoistway, and in the machine room at the top that actually moves that elevator up and down. And so for code purposes, they are as current as any elevators in the city of Lincoln. You walk into them, they look historic as if they were straight from the 1930s. What you see here is the element of the elevator project that was left out. They were installed originally, and it's called a dial floor indicator. On the left-hand side is the outer dial, which has the numbers of that particular elevator set within it, and there's a pointer in the lower right-hand corner that sets in the middle of this like a hand of a clock, and it simply rotates to indicate the location the elevator is in the hoistway. And a detail at the upper right that shows the size of these pieces. A portion of these original dials in the building were cast iron, and a number of them were bronze. For the purpose of our project, we reproduced them all in bronze because it was simpler to do. It was somewhat more cost effective because switching between the two materials is more difficult. And so all of the dials you see in the building today are cast of bronze. Now here is the condition on the left-hand side of what you saw prior to the start of our project. You can see, if you look closely enough, that behind that light bar, which is a horizontal strip with the floor numbers indicated in that strip, behind it on the wall is a shadow of a circle. Well, you just saw what that shadow was. And we knew they were there. We had some original dials from which we could make patterns to reproduce them, and that's precisely what we did. We wanted all aspects of the visual character of these elevators returned to the building, not just them 100% code-worthy, 100% safe, and cabs that looked original. Here you see the same location close up, and you can see the shadow behind it. Take another look, and this is what it looks like when you take that box out that had the light bar in it and the shadow above and below. We completely cleaned this wall so that any match we were going to do, we had to fill in this slot that was carved in the wall rather unceremoniously. There was a metal box in there. We took all of that material out. We had to, as carefully as possible, put back the appearance of stone in that wall so that when our dials went back in place, they looked like they did in 1930. Here you see our mason, Phil Lagoni. You see part of Phil. You see his right arm. And he is filling in. Our shop had to create a couple of things. Our shops did most of the serious technical work apart from the hoistway, the restoration work. The shaft that goes through the wall was made by Roger Frink in our machine shop. And he created a steel tube that went through the wall. And the walls at the lower element of the building are 18 inches thick. Upper level, probably 12 to 14 inches thick. He inserted a needle bearing in the end of each end of that pipe, through which the stainless steel stem that was on the back of the pointer slid through. So it was a completely sealed container that this stainless steel rod went through to keep dust and dirt that is ever present in a hoistway from fouling the works of this thing. And it's a beautiful piece of construction. Regrettably, it's buried in the wall, but it allows these pointers to work with great precision. And on the right-hand side, you can see where he did various lifts of mortar and concrete to get out close to the surface of the wall. Then he came in with 1/4 inch of depth. You can see on the upper left the finished product with the hole in the center of it. And then he infilled with a stone patch material that was the closest we could buy commercially to match the stone. The other trick to this is not just matching the color, but the texture of the stone. Because if you don't get the texture right, the color can be perfect, and you're still going to see it stand out with a pronounced difference in visual care. Now, the final touch comes. Here's the patch that Phil did. He also struck a mortar joint through it, because you can see the mortar joint was interrupted. And the gentleman you see in the lower right photograph is Mike Marshall, our capital cabinet maker, who works very closely with Phil on a lot of projects, and Mike's kind of our colorant expert. And he came along and applied the final color to the surface of the patch to match the adjacent limestone. I encourage you to come into the building today and look up at those, and now that you see where to look, see the patches. In most cases, it's a remarkable transformation. And as I said to Mike when he got done, he says, you know, you can still see a little shadow there. And I said, Mike, give it 10 years of dirt on the wall. And I said, the patch is never more visible than today. It will only get better with age. We had another issue to cover, and that is on the 14th floor, the very top level, the memorial chamber level, we had Casota buff marble veneer, 1.25 inches thick on the wall, and the same slot had been carved into it. Very rough looking. And you can see what the wall looked like behind it in order to ensure, now there are actually 4 slabs of marble here. If you look to the very bottom, you see where the polyethylene's on the wall. Just behind it, you can see the shadow of the slot, if you look very carefully. There are 2 panels down there that have been damaged that we had to pull out and replace with new. From about the location of the top of the tape on that patch that was cut out, from that point to the top, there are 2 more slabs that are untouched. We cut out this sample, sent it to the quarry that's still in business today in Casota, Minnesota, and said we want to match the texture and the color of this piece. And they set us 4 slabs because we have 2 vestibules per vestibule. We have 2 panels, 2 marble panels in each vestibule, so we needed to replace 4 slabs. Once we got our samples and material back, we had to have a couple of sidewalk inspectors come along and check it out. Now, the fellow on the right is Phil Lagoni, our mason, who is the real skilled hands on the job. And of course, the fellow next to him in the middle is Matt Hansen, who's with us today, who's the architect who rode herd on this entire project, getting all the dials in place, working with Historical Arts and Castings out of Utah, getting all the parts and pieces in place, which is a bird-togging exercise second to none. It was a great deal of work, but he did a great job, as did our suppliers of this material. And of course, that gray-haired guy is just a sidewalk inspector along for the ride. Now next, you see a slab, 230 pounds of slab of this new marble, brought up on a 2-wheel truck, and then you see Brett Doherty and Mike Jordan, who work in our shop, hoisting this piece up onto the platform so that our mason and our cabinet maker can put it in place. What you see here is those 2 panels removed that were damaged. Not very glorious behind the wall. Good reason to have a marble panel in front of it. And what you see is a 2x4 standing vertically to hold those marble panels above from slipping out of place. And notice, there's virtually no joint between these panels. There's a 1/16 of an inch joint between them. This is very soft marble, very easy to chip. The slightest touch to it can knock off the face of the piece, so there was tremendous care that had to be exercised lifting this 230-pound chunk of stone into wall twice and in 2 separate vestibules. So the precision and the care with which they put it in place is significant. Here you see them, once they fit it to the opening, here you see Phil and Mike applying plaster of Paris to the back of that slab on the left, and with copper wire ties, they lift it very quickly into the opening in the wall and set it into place. Then they put the second panel in place, mortared the joint, put the dial indicator in place as they did with the shaft that went through the wall in the lower floors, and you have a remarkably good looking product. Go to the building, check it out, kick the tires. It's your building. Enjoy it and see the work that was done. It was fun to do. It's fun to see things like this come from a very rough state back to what was originally there. And it is a load of fun for us who do it every day, and we do it for you. So please come in. Now I'm going to show you as well some other locations in the building where work was done. This is Greg, who worked for O'Keefe Elevator, and he is putting a new floor indicator into the head of the hoistway opening in the basement. We're not positive. In fact, I can't recall whether we had the dial indicators in all floors. But these dial indicators that we put in place, apart from this opening, are now electronically controlled. Originally, they were simply pulleys, if you can imagine, on the shaft of every pointer, on every floor, with interconnecting cables or ropes that went between them, and when one turned, they expected all of them just move the same amount. And imagine how long, about 10 minutes, those things stayed in adjustment. You'd had to have a full-time elevator mechanic back adjusting them every day to keep them there, and I'm quite sure that's why they took them out in the 1950s. It's all done electronically today, so we have solved that problem. In the basement and on a couple of floors in the tower that are not open to the public, we put LED floor indicators that simply show in one lit form, you've seen these, in green light essentially indicates the level that elevator's on, so you can see it. In the floors, we didn't have to put those more exotic dials in place. We didn't. And in these locations, it's not critical because there's no public access to those locations. In addition, our shops restored the cabs. Remember, the cabs date to 1979, and they are walnut veneered with inlay of holly and ebony within them. And as you can imagine, after 20 or 25 years of use, the grain starts to raise, and there are some problems. Here you see in the middle of this bench an elevator door, and to the right of it, you see the back of the veneer that our cabinet maker was able to lift off the surface of that door, lay face down, and get ready to rebond it, and then repair the veneer that had started to separate. Now this is a close-up of what one of those panels looks like. You can see the outer frame of the walnut and the veneer in the center that's diagonal, and then you can see that very light pinstripe of holly, and outside that, the ebony pinstripe as well, which is present on not only the doors in the cabs, but the other three walls, also set into the coffered ceiling overhead. What you see here is one of those doors with the veneer reattached. And these funny looking pieces of tape are actually discard tape measure tape. This is all steel. They're very thin, and you can slip them into the various cracks in the veneer on the surface of the door. And there isn't a piece of tape on the door that isn't inserted in a slot that had delaminated. And you can see the amount of work that was necessary for Mike to do on just 1/3 of one door panel, and there were 4 cabs to restore. So we did an enormous amount of repair to these. And once you get them, you insert with a syringe in these tiny little slots where the grain is raised, you clamp the living daylights out of it. And that is to say, you can't put enough clamps on the surface of these to get that surface down, to hold it in place, get that glue cured, so you set it in place for a day or two, then remove those, clean the glue up, and you're back in business. What you see here is the back of a completely restored cab wall. What you're also seeing is a photograph that was taken a year after these were put back in place. You notice there's a couple of dark bands across that veneer. See one kind of near the bottom and another one about the middle of the screen? Those are our passengers, leaving a little message for us. People don't get in elevators and just stand up. They get in elevators and they lean. And this is what people leaning against the walls, even after 1 year, does to the surface, which requires our staff to get in, clean them up, and keep them finished. So it's a never-ending process. And here you see one of those coffered ceilings at the top of an elevator, and the escape hatch in the center has been removed, with the ganglia of wires that are attached to every elevator in the Capitol and every elevator anywhere, hanging down out of that ceiling, and you see Greg overhead in the hoistway above. Here you see inside the hoistway. These are 2 shots of the hoistway themselves. What you see on the right-hand half of the screen are the counterweights. Now, picture in your mind, if you will, there are basically two types of elevators. On low buildings, low relatively speaking, 4 to 5 story buildings, typically outfitted with a hydraulic elevator. And there's a hydraulic stainless steel piston that goes down into the ground, and it telescopes up out of that spot beneath the cab of the elevator, lifting the elevator to and from floors that are called. You can do that only so far. You can't do that on a building that's more than about 3 or 4, maybe 5 floors. Once you get beyond that point, which the Capitol obviously is, being the tallest building in the city of Lincoln, you have to use what's called a traction elevator. Now that's the more traditional elevator that most people think of. And in our case, as in all traction elevators, there's a machine room typically at the top of the hoistway, the very top of the shaft. And there is a motor up there with what's called a sheave or a pulley. And the cables run from the top of the elevator cab up the shaft, wrap around that pulley, around that motor at the top of that shaft, and then they turn around and run back down into that same elevator shaft. Because somewhere in that shaft, there are counterweights. And that's what you're looking at on the right-hand side. The counterweights are the same weight as the cab itself. So that when you if you push a button on a landing and the elevator's coming to you empty, the motor's doing very little work, because the counterweight's the same weight, and all it does is turn that cable to bring the cab to you. What the drive machine lifts is all of us that are inside the cab. That's what really makes the motor work hard. It's not just moving the elevator up and down the hoistway. Yes, that's an issue, but the counterweights more or less neutralize the weight of the cab itself. So when 4 people my size get in, the elevator says, ugh, I have to lift these guys somewhere, and away it goes. So it is an issue of weight of passengers that really drive the size of the machine. And here you see at the bottom of the hoistway the shock absorbers. They're called buffers. And yes, there isn't a big coil spring at the bottom of an elevator shaft, but there are hydraulic pistons that provide a safeguard for a softer landing should for some reason an elevator lose traction and drop to the pit. Now, understand, elevators are a product largely of the 20th century. And they came about and became in common use because of a gentleman by the name of Otis. You've likely gotten on an elevator or two and seen the name Otis. What Mr. Otis did and demonstrated very successfully at the Columbian Exposition in Chicago in 1893 was the first successfully developed elevator brake. And in this hall of industry, I believe it was, he would stand on a flat platform, 12 to 15 feet in size, and he would raise this platform off the floor, and the cables that held that up were right beside him, and he'd take an axe and he'd cut the very cables that held that platform up, and it would drop just maybe a fraction of an inch or so. Very safe. He said, see, no problem. That's why you can ride elevators and make them safe. His was one of the inventions that caused the first successful development of traction elevators that became ever present across the country and, in fact, across the world. He was the one who did most of that kind of lifting, if you will, or braking, as the case may be, in making that industry successful. It's interesting to note, a little story I learned about when I had the very good fortune of working on a third phase of restoring the Washington Monument in Washington, D.C. several years ago. And I learned a very interesting historic footnote. That project, the Washington Monument, was started in 1848 and progressed only to about 1/3 its current height. And if you look at it closely, you can see what looks like a water line on that. That's where it stopped at the Civil War. And it sat there languishing for a time with trees growing out of the monument and those sorts of things. But when they reactivated it and completed this project some 40 to 50 years later, they had a lift, a material lift built into the center of the monument. That's where the current passenger elevator sits. And the shaft that holds it up is all cast iron with rivets. It's very interesting to see. Very historic framework that holds the machinery of the elevator. But right after the monument was first opened, elevators didn't have successful brakes. They were considered very, very risky. And they hauled materials on it, and construction workers got on it, but they did so at their own risk. And when they first opened the Washington Monument to the public, sorry, I laugh when I first heard it, and when I think of it, I still do today. It was considered far too dangerous for women to ride on those elevators. Men, it was okay. So you can see these guys with these top hats and these askets and these waistcoats and these sorts of things, striped hats, getting on and riding the elevator to the top, while the women in their floor-length dresses and bonnets and those sorts of things were walking the staircase around it. It's a vision that I can't get out of my head and is one of the most convoluted things I could imagine, but it was all because Mr. Otis hadn't come along yet and developed a good brake. So now that we have elevators safe enough for women to ride in, we have buffers to make sure that should there be any possible mishap, that an elevator has a buffer. And that is what that is. The large piece more in the center of the shaft is for the cab itself, and the one back against the back wall is to catch the weight of the counterweight. And there's that very same elevator buffer pulled out. We kept one of these, and that piece is probably about 5 feet in height, and that steel cylinder on the top about 6 to 7 inches in diameter. And here you see some work that we did. Now we're getting out of the not very glorious part of this whole project because we don't see the floor indicators, we don't see the cabs and all the things that the public's meant to see. This is what elevator mechanics had to deal with when they did ongoing maintenance of the 2 elevators that went all the way to 14. Remember, the 2 north ones go to 14, the memorial level, and the 2 south ones only go to 12. Now their machine rooms are one level up on 13th floor, which you can open a door and walk into. The machine rooms above 14 are just whatever space was left over above the shaft. And in one of these machine rooms, I cannot stand up. Now I'm 6'4", it's a little more problematic, but the ceiling in much of the space there is 5 feet or less. So you had to be a contortionist, you had to be pretty limber, and you had to be very strong to work on our elevators. And what you see here is a 16-inch wide steel ladder that a mechanic with perhaps a 30 or 40 pound toolbox would have to step into and go up this ladder about 15 feet, step off through a 3-foot by 4-foot opening in the wall onto the floor of a room that was only 5 feet tall to work on this machinery. Now, the elevator inspector at the time, Bud Witt, said, I think this is an egregious thing to put somebody through, and we couldn't argue with him. And he said, if you want my approval for these elevators, you're going to put in a stair and landing system for the mechanics to go to. And we thought, that's a good idea for us too, because the owner wants to go up there and check things out from time to time. So we very gladly cooperated with his requirement that we put in better access to the machine rooms. And here you see an interior view. This is like building a boat in a bottle. This is a small space at the top of the tower, and this stair was brought up in sections and welded together in this location. It's all galvanized steel, and it's beautifully put in place. A good friend, Dennis Clavon with Bar Vermeer and Hecker Architects, was the fellow who had the task of crawling around up there without having wings. I'm not sure how he got all the dimensions that allowed it possible, but he managed to figure out a way to shoehorn this little boat in a bottle into this room to provide access to a landing level at the very top. The stair comes in at the back left, and you can hit this platform, which is the same level as the machine room floors. And you see that little box beyond the handrails around the stair. That's about a 3.5 foot tall by about the same dimension wide opening that is the doorway to an elevator machine room. They're now covered with hollow metal fire-rated doors, but when the men were using the ladders, they had to go straight up a ladder and step off the ladder into one of these tiny little slots, push their toolbox ahead of them, no doubt, to do ongoing maintenance and repair for our system. Much simpler task today. Here is an original machine, drive machine. This is one of those motors that sits atop the hoistway and lifts the elevator up and down. This is a machine that dates to the 1950s renovation. And you see the outer ring of that machine is a little over 3 feet in diameter. And what you see on the right-hand side are the old solid we called click and pop relays that were the controllers that determined how the elevator moved within the shaft. That rack on the right literally did click and pop. You stepped into that room and it would snap and it would pop, and with every one of those sounds came sparks flying, and often on the brushes there might be bits of carbon and so on sloughing off. So this room was always kind of dusty and full of graphite dust, it seemed. As well, it produced a great deal of heat and sparks. It was a very uncomfortable place to be, and it was very, very uncomfortable to be in there to work. This rack on the right was replaced with all electronic circuit boards and all the technology of today. On the left, you see a drive machine that is the size of a small car. It's about the size of a Volkswagen. Here's a similar machine room. Like I said, remember those ceilings 5 feet and under? I wasn't lying. This machine is sitting over the hoistway, and you can see the control panel to the right and behind that particular piece of machinery. Whoops. Am I going forward or am I going backwards here? There we go. Now, this is a comparison between the old click and pop controllers that we saw. On the left-hand side, the panel on the left is 9 feet tall, and it is about 5 feet wide, and it's in addition to a controller, it's a large heater because it produced an enormous amount of heat. What you see on the right-hand side is about 1/4 the size of that old panel. It's about 4 to 4.5 feet tall and about 30 inches wide. So it's literally 1/4 the size of the panel you see on the left. With all the electronic circuitry and so on of today, far more efficient, far less heat producing, no clicking and popping. And to make it one better, we installed air conditioning up here. And in the slide or two, I'll show you what that is. This is an old governor, not the elected kind. It's a motion regulator. It is the one that limits the speed of the elevator up and down the shaft. And this piece was taken out because we think it may well be original equipment to the building. And so when we find pieces that are original to the building, we keep an example of them. And here's a new version. The one you saw in the previous slide was about 5 feet in height. This is a wheel. The yellow part is 18 inches in diameter. So you can see how much smaller it is and how much more efficient. As well, this is a new drive machine. Remember I said the outer ring on those old drive motors were about 3 to 3.5 feet in diameter? This particular piece is about a little over 2 feet in diameter. And you can see the size of the steel beams underneath. Those are less needed for carrying the load and more needed to make up the vertical distance that the old machine used to take up. They needed to have those pulleys at roughly the same elevation. And here is more or less a completed machine room, new control panels in place. You can see the drive machine at the back sitting on those beams, and you can see the yellow wheel of the new governor sitting behind them. And here's that air conditioner, which was required in every machine room. These machine rooms are now all built to fire specifications, to an hour to 2 hour rating, so that any fire that might occur there is taken care of with all the fire protection and detection equipment necessary, as well as the rooms themselves are conditioned to make the equipment run more efficiently and to make it last longer. And I'm down to my last slide here, which is a door to one of the 13th floor machine rooms, which is access to the equipment that runs one of the 2 south elevators that only goes to 12th floor. Now I call your attention to the door because the lower 20% of that door is a replacement panel, because the heat was so great in those machine rooms previously. There were steel grills that cut out the walnut panel in the center and put a steel grill in the door to let some of that incredible heat out of there. And what you see on the right-hand side, unfortunately it's a little bit reflective, but you can see a line across that door panel where that replacement piece of wood was put in place by our cabinet maker, Mike Marshall. Steve Jansen in our finish shop took care of the finish on the door, and the door was essentially restored. Immediately behind this door, 12 inches behind that door, is a hollow metal door and drywall partition to fireproof the room beyond. We didn't take the original door out, we simply concealed the new fireproof construction behind the original door, which is not, this one you see is not necessary for the fire protection of that room, because the door just inside it provides that level of protection. So this concludes my general narrative on what we did in the restoration and, in most cases, restoration and renovation of the equipment and for the 4 tower elevators. Come over and look at it. The things you'll see, we think look pretty nice. The things you don't see, we think look pretty nice also. But you've seen more than the general public will see when they come to the Capitol. And the vast majority of that $2 million we spent was on what is in the hoistway and in the machine room. And because we have the talent on staff that we do, we're able to make very, very cost-effective adaptations of restoring the cabs, putting those dials above the doors. All of that work was done by our people, which the O'Keefe Elevator Company was able to attach to make the system work the way you'll see it when you come to the building tomorrow or this afternoon. I'll attempt to answer any questions you might have about this project if you have some. Yes?
Seeing the size of the piece of marble that you were using on the 14th floor, and knowing the size of those elevators, did that marble fit into those elevators?
Yes, it did. Fortunately, when we have to move large objects in the tower, if it doesn't fit in the cab, we often go on top of the cab. And it moves at inspection speed, which is very slow. But there's enough of a kind of a platform above there. We put large pieces of furniture up there. We try not to, but it is possible to do. But those slabs were clearly small enough to fit in the cab themselves, so it worked well. Yes?
Bob, I think it might have been inadvertent, but when you were talking about the car operating panel,
Yes?
I think you jumped over about 2 slides.
Uh-oh.
You can use your forward and back arrows to get back there to show what the new car panels look like.
Well, those forward and back arrows worked before the presentation.
Okay.
They're not working now, I regret to say. So let me see if no.
Maybe you could go up and
Here's where my technical experts. I don't know, Matt.
Let's see.
You may know the ones that skipped, so I'll have you do that. At any rate, is there another question? Yes, you had your hand raised?
Yeah. building for the first time and probably in the early 1950s.
Uh-huh.
And I have no recollection of going up the elevators, but I'm guessing that I probably did. What would the elevators have been like, say, in 1951?
The question was, if you went into the Capitol in the 1950s, what cabs did you see?
Yeah.
Or would you have ridden in? From about 1953 on, I think you were riding in a Formica cab. They were not really very pleasant, and they had nothing to do with the original character of the building, but they did suffice for about 25 years, and there were 3 of the 4 elevator shafts that had those put in place. I can remember them because they were there when I first started to work at the Capitol, but were shortly thereafter removed, and the new replicated cabs were put in their place.
What about, say, in 1950, just to go back to
1950, you might have been there when in 1950, if you were in the elevator cabs, you would have probably ridden with an operator
Yes.
who would have been standing there holding on to that dial, and if you got a playful operator, they could make those things fly, and they could make them drop very, very readily, almost free fall. So you hope you got in with someone who was pretty well balanced and was operating the controls.
When did the operators
Cease?
no longer?
The operators ceased. Interestingly enough, I started in the Capitol in 1975, actually working there, and they had the automatic push-button cabs from the 1950s still in place. And when I started there, they still had operators in there who would stand there and push the button for you. An operation I never completely understood. It was kind of a make-work position, but eventually, before I left, and they would have, believe it, those elevators are small, and oftentimes those operators were not standing in the cabs; they were seated, so they took up the space of at least 2 people when you got on the cab. Yes.
The clear at the top of the tower, I don't know what that beautiful space up there.
Yes, the memorial chamber on
Yes,
14th floor.
Okay. Have people always been able to get up there, say back to 1950, just to pick a date?
Yeah, the question was, has the 14th floor always been available to the public when they got on the 2 north elevators to go up? And to my knowledge, there's never been a time that the public couldn't go to that level.
Okay, well, I thought I remembered that from
When I was a boy, I would go up there, and that was before the murals of 1996 were put in place. And the room was without murals, but was very, very impressive, dark green and black marble, and you could rise to 14. You could use the 4 outside viewing galleries to look over the city, and then that octagonal room with the dome above was an impressive place to see, but seemed to have virtually no meaning because the murals gave that narrative, that definition to what the memorial chamber was really all about. Yes, sir.
Just to pick the Sears Tower in Chicago.
Uh-huh.
Would the mechanics for the elevators to go up and down there be similar to this?
They would be. And the question was, with very tall buildings that are much taller than the state capitol, have many more floors, the Empire State Building, the Hancock Tower and others in Chicago, those very tall buildings often have more than a single bank. They will lift people to the midpoint of the tower. Then you step off of that bank of elevators, move over, and then there's a bank of elevators that start at that point and rise to the top. In fact, there are some instances where there are 3 separate sets or more of those because they really, it's kind of counterproductive and I think relatively unsafe and difficult to coil up enough cable that would hoist an elevator more than about 400 feet, 500 feet. And I think, I don't know what the limit is, but I do know they start using banks of elevators, and you step off of one to go from the 50th floor to the 100th floor, let's say.
But those cables, they are still pulling them up?
Oh yeah,
the
absolutely.
cables?
It's the same basic operation as you see here. Yes?
So, were any of the materials from the cabs salvaged from the pre-50s when the Formica went in?
Very good observation. The question was, were any of the original cabs, the original wood cabs that were taken, 3 of them taken out in the 1950s, were any of those kept? Since in 1979, for the very first time, we took the last wood cab out, that cab was largely kept. It was in very rough shape, as you can imagine, after some 50 years of use. And so we kept what we could of that cab. It was very beat up. It had, not formica, but it had masonite from about the 4.5-foot level all the way to the floor, because the bottom part of the wood cab had been so mauled with freight going in and out over that 50-year period. So there clearly were elements of that original cab that were there, and what was original we did keep. We attempt to do that whenever we can. It's not every second, third, or fourth generation replacement part that we keep. It tends to be the original equipment to the building, which is the prototype of what we work from for future work. Yes?
And that's what I was gonna ask. So did you work off of that then as a prototype, or did the plans, the original plans to the Capitol provide enough detail for you to follow so that you know what the original cabs would look like?
We had the original drawings as well. And we know that the original cabs were not built as originally devised. They had to lower the coffering. The coffered ceiling kind of steps up like a pyramid might, but on the inside. We know that they had to lower the height each one of those lifts were when they built the original cabs. So we know there's some modifications because we fortunately have most of the drawings that were required to build it to begin with. Roxanne, did you have a question?
Okay. On that left-hand side, is that the original?
Yes. What you're seeing here is kind of a microscopic view of the work we did on reproducing the control panel inside the cab, the one that you and I step into and push a button to change floor. On the left is the original casting, and you can see that kind of stippled background, the bronze border on the outside, as well as the polished raised border on the interior. Next to that is the 1979 attempt at reproducing the same panel. You can see the texture on the back is not the same. The casting is rather crude, and although this photo on the right is a little bit fuzzy, the detail of the border on the panel on the right is the one that we reproduced today, and it is very accurate because they recut and resculpted the border instead of just take a mold off the old one. So that's all new, and you can see the stippled background is far closer to the original finish. So we went to the greatest extent we could to replicate the finishes on this particular reproduction panel, which was the fourth panel that's been in the cab. And I'm glad Roxanne asked that last question because I owe her a great debt of gratitude for putting these slides together for me. She went into the project files while I was working on other things and put together in chronological order something that made sense on the project. So Roxanne, my thanks to you. Tom?
I think you have one more slide.
Do I? Very good. Good. Now, this is the finished control panel that you see in the building today. And you'll notice this is for one of the south elevators because the top floor only rises to 12th floor. There's room at the top, as you can see, for two more buttons to be inserted, 13th and 14th floor for the two north elevators. And on the right-hand side, you see a close-up of those buttons, which not only have raised numerals for the average visually impaired person to be able to read with their fingers, but for the small percentage of visually impaired people who have the ability to read Braille, Braille is immediately beneath it. So there's two ways for the visually impaired to be able to tell what floor they're rising to and what button is immediately adjacent to that numeral. Yes, Matt?
Can you talk about the control changes and operation of the buttons from how it had been with the keyed system?
Yeah, Matt raised a good question. What you see here today is similar to what the previous panel was and how it had operated. The previous panel allowed us to create buttons that were large enough in diameter to pull out a button and insert a lock cylinder, which you could put a key into to gain access to the floor in the tower. This new panel, which you see on the left, does not allow for key cylinder lockout. It's a much smaller diameter, about the diameter of a quarter. And you notice the lower left corner of this panel has a little red box there. That is actually a scanner for an ID card, and we now program people to get on to the tower floors. Our office, who work in the building, have cards that you can scan and you can hit any button on the dial and go there. Other people who work in the tower, if you work for one specific agency, perhaps you work on 9th floor, your card will scan and it will only allow you to gain access to 9. It won't illuminate any of the other floors. So they can program who has access and who doesn't. One of the complications with doing away with the lock cylinder is it is not an obvious block to people's access to the floor. The south elevators will allow the public to use 1st, 2nd, and 3rd floor access. When you want to go above that, you push the button, it lights when you push it, and you take your finger off and it goes out. And people will sit there punching it and wondering what in the world is wrong with this stupid button. Well, when you had a lock cylinder there instead, it made it very obvious. And you thought, oh, gee, it takes a key to get up there. Well, I'm not going to sit there and push on a lock cylinder. So we lost the rather obvious nature, the kind of the crowd control feature that was provided by the use of lock cylinders in deference to what code requires, which is simply blocking out the use of a button that now gets 25 times more pushes because people get frustrated because it doesn't remain illuminated when they push it. So, yes, Roxanne?
Do you remember how fast the elevators go now?
You know, I should be able to remember that. But some of those details, the question was, do I know the number of feet per second that the elevators rise in the hoistway? I do not. I don't recall. I know they are at the maximum speed. I believe we can place them, so they move much more quickly. The roller guides in the hoistway are really incredibly improved over the old ones, so the elevator cabs don't rattle and move around and kind of make the noise or the motion that they used to. So they move much more smoothly. The elevators now are as comfortable and easy to use as any that I've ridden in a high-rise building in recent years. Yes?
Isn't it like a quarter of a mile a minute or something? That it takes them like 15 seconds?
It's
now to get to the
rated
top?
it's rated in feet per second or feet per minute, and I do not know it in terms of miles per hour or anything along that line. Yes, John?
Is that a current panel?
It is.
Have you thought about putting a sign there that says you have to have a card access to get to the floors that I couldn't figure out how they worked a year ago?
Good question. The issue tends to be that people don't read signs.
They don't read those.
No. And well, they can't. But, you know, you can put a sign there, you could wallpaper the cab with signs, and they won't read them. We used to put a little card sign above the call station where the up and down buttons are on the landings, on the floors where you want to go up. We put a little card there and says, this elevator does not gain access to the top, to the observation level. No access to observation level. And after we put those cards in place, I came upon a mother, father, and 2 kids. And they were standing at a south elevator. I said, do you want to go to the top, to the observation level? Yeah, oh yeah, absolutely. And I said, well, this elevator won't take you there. You see this sign? And they said, uh-huh. I just continued to push the button. And I said, no. I said, read the sign. I said, it doesn't. I had to do it about 3 times. And then they finally went, oh, another elevator. So that has nothing to do with the intelligence of the people who are riding the elevator. It has to do with their powers of observation. And I've been forever amazed at how ineffective signs can really be. No matter how large, no matter where they're placed, people will either choose or not choose to read them, and most are the latter. Yes, question?
Yes. On the old generator, the noise emitting from the old one to the new one, is there a vast improvement or the same amount of noise?
You mean in the machine rooms? Is that the issue? Yes. The question was, how noisy are the machine rooms now? They're virtually silent. The clicking and the popping is gone. The rumbling and the spinning of the motor that used to drive the cab up and down the hoistway is just all but disappeared. Not to mention the fact where there were doors and people were seated on the same floor as a machine room, there's now a steel fire door inside the walnut door that you see, so there's a double barrier to help block what little noise there is there now. So it works very well. So I think we're about out of time here. Any other questions real quickly before we close? Thank you for being here and thank you for your questions.